our next project, we're going to go to Ocean Springs, Mississippi. We have Trace there, and he's going to do a little something on tool steel and grinding, etc. And we put off his demonstration on sharpening a tool until next week because it's running a little longer than what we plug in for demonstrations tonight. But this will be the third demonstration of the evening, and I got to thank Trace for being in there. Trace, you start, and one of us will co-host will pop you in there. There you go.
Okay, I got
it, buddy.
And what I'm going to do tonight, instead of doing the full up sharpening demo, I want to talk about some tool steels, so you have a better understanding what some of the different steels are. And then I'll do a little bit of sharpening on some of the peripheral things like a drill bit or some other specialty tools, threading tools, thread chasing tools and some of that. And we'll actually get into the real demo on sharpening our turning tools next week because of time. So let me switch. Okay. Okay, this is a listing of some of the tool steels out there and the contents of what's in them. From carbon, magnesium, silicon, chromium. Can everybody hear me?
Oh yeah, go ahead, please.
Okay, okay. Chromium, tungsten is W, molybdenum, palladium, nickel, and sulfur are the contents in here. When I started messing around with tools a long time ago, I was using the 01 steel, which is an oil hardening tool steel. I did it because it was the easiest one to heat treat. A lot of these have very complex heat treat schedules. You go to 1200 degrees, you hold it for 2 hours, et cetera, et cetera. So the 01 steel, if you're going to do stuff in your shop, is probably the easiest one to deal with. And the reason why is the heat treatment on that. You heat it up red hot, you quench it in oil, clean it up, and then you put it in your oven at 450 degrees for about half an hour. And that's the only thing required to heat treat it. So it's the easiest one to do at the house. But the other thing I want to talk about, some of these other, the different type of steels that we have in the turning tools. Now, what's not in here is your old carbon steel, which a lot of knives were made from a long time ago. A lot of the old turning tools are made from carbon steel. And what that is just iron and carbon. Nothing else mixed into it. You can get a real sharp edge on it. It doesn't hold the edge a super long time. And it's more sensitive to heat, the heat problems. Now, and the newer steels that we have, you have the M2 steels, M4, the V10 and V15 is not even listed on here. But let me explain what the CPM stands for. That is crucible particle metallurgy. Fancy name, but what if you look at these steels and you start looking at them, you'll see that some high percentages of some of these alloys that are added to it. And what happens with that is when they heat up the thing, mix the iron with the alloys, and then they pour it into an ingot to let it cool. Well, when they pour it into the ingot, you start getting separations inside of the what's melted as it cools, which is not good for what you have. You want everything mixed together with small particle structures. Well, they found out if they produce a powder with it coming out of the furnace, produce a powder, each one of those little grains of powder acts like an ingot. You don't get the separation on it. So you can put you can mix a lot of the other metals in there to get the what you need. And so they come out of the furnace with powder. Then they take the powder and heat it up just below melting temperatures. They keep it below melting temperatures, put it in a press and put a lot of pressure on it and reform it to a solid steel bar. And that's what the CPM steels are. And they have a lot higher properties. Let me go to a property chart here. And probably the magical and most important one for us is the blue or purple line across the middle. That line is wear resistance. That means that's how long the tool is going to stay sharp on the lathe. And you look at the oil hardening, it's 1. Your air has got a 2 on it. Some of these are improving. M2 has got 3 bars on it. M4 has 5 bars on it. V10, I didn't count the number of bars, but it goes across the screen with it. So your V10 has will hold the edge longer. And V15 is about the same. It has a little higher properties on air resistance. So that's just a quick thing on some of the different steels that we're dealing with in tool steels to give you an idea of what's going on with it.
Okay.
Very cool. Thank you.
And that means you understand what the steel is. That's an important little thing. Okay, let me switch over to this camera here.
Well, I know that chromium gives you stainless, and I know that molybdenum makes it harder.
Yeah. And the nickel helps you on the stainless too. So
Cool. Yeah, both of which are resistant to rust. Yep.
yeah. Okay, now I'm gonna sharpen a drill bit. I just had it here. This is just a standard drill bit. And see if I can zoom in a little bit further on it. Okay, got about the right angle. Now to sharpen this drill bit on the grinder, that's an angle on it, and that's back at an angle. So you're going to start with it about at that point there. Now, you normally think you just rotate it, but if you rotate it, this side here is the same distance out as this side. So what you need to do is as you rotate it, you need to push up on it, which will give you a back relief angle on it. And let me just show you how it's done.
I don't know about you guys, but that's like below my screen of view. I can't really see what
Yeah,
he's doing.
you got to drop camera a little bit.
Okay, that's a sharpened drill bit.
Trey, can you do it again and drop the camera about an inch? Your presentation was below the camera. That right, that might work. There you go, folks.
Okay.
He's not changing the angle.
Okay, you go straight. Now I'm lining this up here with it. I'm starting out with this horizontal with it into it. I push it against it, twist and push up. Put it against it, twist and push up. So I'll just do it again one more time just to show you, but this is horizontal. It's going straight into the center. Push in, twist, push in and twist. And that's how you sharpen a drill bit.
You know, some of the things, you listen to what he just said, sharpen a drill bit. He didn't reshape that end. He didn't change the attack angle. He just sharpened the blade.
Yep. But here's the bit I just did. You maintain the same angle going in, and that edge is sharp. Now, the drill bit, you have to have relief from here to here, because if you don't have relief, it'll bog down. You're pushing it in, the back rubs, and you don't get it doesn't cut. But that's it on sharpening the drill bit. It's easier to start with a big one, but once you start with a big one and start doing it, I've sharpened drill bits down below 1/16 of an inch. Doing the exact same process. I use a little bitty small cutoff tool with a flex shaft or something to do it with, but I've sharpened the little tiny drill bits the same way. Now, what I'm going to do today on sharpening, I'm just going to do a couple quick things, and then we'll get into the main sharpening next time. Okay, this is a thread chasing tool, and the way I sharpen it now, I can't do it here because my thing is, I am going to rest my tool on a surface to sharpen it almost all the time when I sharpen something. I don't do it in freehand. I don't have the thing that can, well, I do. Let me slide it across. Okay, now I got something to rest on. I'm sharpening, and all I do is sharpen the top of it. That's sharp. That was the outside. This is the inside. Same thing. Just hand hone it. The other tool I wanted to show you, this is a homemade tool, but I copied it. This is a ring tool. It's made with the 01 steel, and it is sharpened. It's the same thing. I'm gonna sharpen it from the top of it on both sides. Well, I didn't get all of it, but that's close enough. That is a ring tool. And basically it goes in this way and then rotates around and it does your undercut and does the top of it. Now these actually are sized. You have to have a different one for each ring diameter or each ring diameter on it. But these were homemade tools made with the 01 tool steel.
And the beauty is you can, if you have a, I gotta be careful how I say this. You have older tools that you've replaced with newer tools, don't throw them away. And that's what you can make these ring tools out of.
Yep. And basically this is made by drilling a hole, simply drilling a hole, drill a hole, and then cut at an angle across it. And then it's tapered to go in tapered. And it does a great job of cutting rings. You cut it all the way around, it gives you a fairly clean thing on the back of it. Last one I want to sharpen is going to be a Forstner bit. I get some of the stuff off the background. Now the Forstner bit, I'm going to sharpen with a diamond hone. And again, holding it on its edge. There are two edges I'm sharpening on this. One is this edge right here. And the second edge is going to be right here. But this first edge is nothing more. And if you'll notice this back part here, that simply rides on it. So you very simply just go back and forth with that.
Again, you're not reshaping edge, you're just dressing it.
Yep. But that just rides right there. The last one, you need a rounded part on it. And this is just riding this way on this. Okay. And that Forstner bit has been resharpened.
Boy, you talk about make a difference from the heat you generate, folks. When they sharpen, they don't generate as much heat.
I know what I'm doing tomorrow.
It'll do you a cleaner, easier cut.
You know what I'm doing tomorrow.
I always worry when I see somebody doing a demonstration using a Forstner bit to do the boring. I don't worry about them. I worry about the novice turners that are following them. It says, I don't get that with my Forstner bit. This is why.
So, hey, Trey, on the Forstner bits, I always sharpen the flat. I don't touch the top.
Well, that top does a slicing motion on the side of it. So it usually doesn't dull near as quick. So a lot of times I may sharpen the flat 3 or 4 times before I even touch the side.
Okay, gotcha.
So, but you do need to look at all the cutting surfaces on it to improve, to make sure they're clean.
Boy, that's a good one for you. The clean part. If it's all gunked up with that CRAP product, it is not going to cut.
And if you look, and also if you look at that side piece, it's a slicing action on the side. It's a slight angle with that slices down through the wood on doing it.
Yeah. You're not getting nice little curlicues off of it, just like a lathe tool. It needs to be sharpened.
Yeah, you should get but the peeling action is from the middle. Now, the other thing I do when I use the Forstner bit, I put air in my hole. I blow air down where I'm drilling and blow it down the hole as I'm drilling. It does two things. It clears the chips out and it keeps it cooler.
Good cooler.
And I have found that most of the time when I drill my little birdhouse and stuff, it's a single pass. I just put it in and drill. It all clears the shavings and everything. My bit doesn't come out hot. So, and I'm drilling into ingrained oak and everything else. And it seems to do very, very well with doing that. So, that air helps a lot. Now the air end piece I use is the Harbor Freight, that little Harbor Freight end piece that you twist. If you know the one I'm talking about. I've got one here.
Folks, this is a live demonstration from Tres Lennep in Ocean Springs, Mississippi. Oh yeah.
Okay, this is what I used to blow the air down it. And the reason why I like it is the amount of air you have is controlled by twisting this. So you can turn your force down and don't have to worry about holding the air pressure. If you have a normal air blower, you're trying to put too much air in it. This one allows that adjustment. They're only a couple bucks at Harbor Freight, snap directly into it. I highly recommend using it for blowing that, or even blowing stuff off the lathe and everything, because you can control how hard it blows and keep your dust down. But it works great. Stick it down on the edge where you're drilling the hole, and it keeps the shavings cleaned out.
Very good. Good tip on that.
Yeah, I carried something like that in my nail bag for years as a carpenter. When we first started using air-powered nail guns, because it was good to clean up with.
Yep.
Always got a safety write-up if you clean it up without safety glasses. See, Jeff, I'll listen.
Okay, well, I'll tell you what, this will be all for this evening. Next week, we'll talk about doing the bowl gouges. I'll show the standard Wolverine system and how to do that. I'll show three or four different ways of setting how far your tool rest is out from it. Talk about the different changes and when you change the angles of it and what that does to it. And protrusions on it.
Grace,
Yes.
when you were talking about steel, Doug Thompson's tools, is his considered that V10 or whatever?
His is V10, and I believe I saw on his website you can get some of the gouges in V15. All steel is V10. Every one of his gouges.
He cryo treats his too, doesn't he?
Yes. Well, and the treatment on it varies. There's significant treatment differences on every one of these tool steels. He sends them off and has it heat treated. And its current treatment does have cryo into it too, which is the sub-zero temperatures. I think right now, from what I'm seeing on steel, some of Stuart Batty's tools are V10, V15s. I know his scrapers are. They have a little insert in them. That's a V10, V15 insert.
Folks, we're not promoting any brand names. We're explaining something about metals and materials.
Yep. What he's done here is he has an insert into it. The insert is V10. The rest of it's just steel. And all of Thompson's tools are V10 and few V15 gouges, if it's special ordered. Now,
Trey, is that because of the palladium that they put in there?
the V10 has
Vanadium.
the vanadium is the, let me see which one that was. So that's V. Yes, it has almost 10%. It has 9.8% vanadium in it.
Okay, thank you.
And when you get those higher percentages, that's the reason why they've had to go to the powder technology to do that. Now that steel is significantly more expensive than regular steel. That's the reason why his tools are so expensive. The metal itself is very expensive. It's an expensive process to do. And the 15, I think, has about 15% palladium in it. So, which has more wear resistance, because I think the wear resistance is the key thing that we're playing around with
Right?
on the tool lasting. Yes.
That being said, when you fooling with steel like that, does it make it that much harder to sharpen?
It's some of it is harder to sharpen. Yes.
Okay.
But the,
Ray,
according to
how does
Doug,
the V10 and the M4 steel compare?
Um,
M4 is 4% vanadium.
M4 or M42.
I don't know what M42 is. M4 is about 4%. M2 is about 2%, a little less than 2%. I don't know what 42 is. It's not on my list, so I don't know that. Switch back to the. Okay, that's the contents in it. If you'll notice, the second column from the left is going to be the selenium in it, and then this is where you get into the grindability and the how it wears. And we'll look at the end. The grindabilities are okay. They're not at the top of the scale. The CBN wheels seem to sharpen them very well. Some of the other rock stones don't sharpen the V10 steels as well. They seem to chip it out a little more than sharpen it. So
Is there any chance we can get these two charts on the website?
I'll extract them.
Or we can probably just go to hudsonsteel.com, right?
Yeah, you can go to hudsontoolsteel.com, and that's where the charts are.
You wonder where the name is, folks. Look at the top of your screen. There it is. So,
And I'm pulling it up off his website right now. This is directly off the website.
That M42 is 1.2% vanadium, but it's also 8% cobalt.
Okay.
Right. And 1.6 tungsten and 3.9 chromium. And
Well, I just went to this one website, and what I liked on it is that it had a lot of the steels that we use on it. It doesn't have all of them. There's some A steels I think I've seen advertised and stuff, but this at least gives you an idea of what the different steels are and what CPM is in the way of steels. You know, what are you getting when you go to the CPM with it? What do you get with those steels? And the bottom line is you get the ability for them to mix more alloys, higher percentage of alloys in the steel, and still maintain uniformity in the steel.
great. Boy, I tell you what, steel is a magic thing, and we really got into it tonight. Thank you, Trace.
So